Hey guys, this is Prithvi Singh. Welcome to the Java Gladiator. In this video, we will understand slices in Go language. Slices are like array, but array is fixed length, whereas slices are dynamic, so they are frequently used in Go language. We will cover these points in this video. First point is how to declare a slice. There are two ways. First way is a make inbuilt function, and the second way is slicing an array or slice. In second point, we will see internal data structure. So internal data structure is array, but we will deep dive into this and we'll see the three important components of slice. In third point, we will see built-in functions like line, cap, append, and copy. And the last point, we will see slice installation, and we will also see the comparison between slice installation and array installation. Let's start with the practical. Let me declare a slice using make built-in function. Make function takes three arguments. First is slice type, second is length, and third is capacity. We'll discuss length and capacity later. Our main focus for now is to understand slice declaration syntax. We haven't assigned return value of make to any variable, so let me assign is to s1. It is giving me compilation error because we have declared s1 but not used. So let me just print this s1, say s1, and now run this program and see the output. So go run slice.go. It is saying 000 because we haven't assigned any value to the slice rate. Now this last parameter, this capacity, is optional. If you don't provide this value, it will take length as a capacity. So length and capacity is same in the syntax. Let's run this program, see the difference. There is no difference, their value are still same. Now we will see the second way of declaring slices. So let me just clean this console and remove these lines and start with second way of declaring slices. The second way of declaring slice is slicing an array or slice. So let me just declare an array first, array of 5 size of integer and initializing value with 10, 20, 30, 40 and 50. Let's slice this array from index 2 to 4, say a2 colon 4, and assign it to s1, and now print that s1. So fmt dot println s1. Now also print length and capacity, length and capacity as well, say cap, and run this program. Go run slices do go. Please notice this output. S1 contains 30 and 40, length is 2 and capacity is 3. Now we will deep dive into the syntax and understand what is happening behind the scene. When we slice an array, we need to provide start index and end index. This will create a new slice from start index to end index minus 1. Here in this example, start index is 2 and end index is 4. So our slice will contain elements which are available in start index 2 to 3. The values available on this index are 30 and 40. The most important point to note here is this syntax doesn't allocate new memory for the slice. This slice S1 will point to existing array A, and the slice has three components, that is pointer, length and capacity. The pointer points to the array index from where slice starts. In this case, pointer points to the index 2. The length is the number of elements in the slice. In this case, slice contains 2 elements, so length is 2. The capacity is number of indexes available from slice pointer to last index of underlying array. In this case, slice pointer points to the array index 2 and last index of underlying array is 4, so total capacity of S1 is 3. Let me ask you a question. If I change start index and end index to 1 and 3, what will be the length and capacity? If your answer is 2 and 4, you are right. You understood length and capacity concept clearly. One more important thing, I am saying slice points to existing array, but how do we confirm this? I will update 0th element of the slice and that will reflect in underline array. So we will try this in the code. First we will revert our indexes 2 and 3, so 2 and 4, and comment these lines for now, and I will update this 0th element of this slice, say 60, and I'll print slice and array before update, so say fmt.println and say before update a array, say a, and again before update slice, say s1, and now I'll say after update. Just copy this and paste it here and say after. Here as well I'll say after, and run this program and see the difference. You can notice that before update array was 10, 20, 30, 40, 50. Before update slice was 30, 40. After update array has 10, 20, 60, 40, 50, and after update slice has 60, 40. So we have proved here that if we update any element of slice S1, it will actually update internally array A. Since 0th element of S1 is pointing to second element of A, so when we updated 0th element of S1, it is reflected in second element of A as well. We can create multiple slices from one single array. So I will create two slices which are overlapping to each other. First of all, I will just clean this console, clear, and remove these lines. I will create one more slice S2 from index 3 to 5 and print these two slices. So fmt.println S1, and I'll print S2 as well. Say S2. Now we will just run this program and see the output. So say go run slices.go. Here 40 is overlapping in these two slices. So it means that third element of A is shared between these two slices. So third element of A is 40. So if we replace this 40 with new variable, it will reflect in all three variables. So let me just update S1. First index will be 100, and let's see what happens after this update. So let me just copy this again and print after this update, and I'll just print A as well, say A, and I'll also say fmt.println, and I'll say after run this program. We can see that 40 is replaced by 100 in all three variables. Now it is confirmed that slice doesn't allocate new memory, it points to existing array. And if we modify anything in the slice, it actually updates in the array. Now we will see how to add new values to the slice. We can use built-in append function to add new values to the slice. If there is space available in underline array, means that capacity is more than length, and if we add new values to the slice, it will update next available index of underline array. So let's try this in the code. So I will just append new value to the existing slice s1. New value is 60, and assign this back to s1. Okay, let's first understand syntax of append function. The first parameter of append function is slice, and second parameter is always the value you want to append. We can have multiple values to append here, but we will just have one value for now, and we must assign return value of append function back to the slice. Now we will print slice s1, array a, length of slice and capacity of slice, and see what is happening behind the scene. I will first print array, so say fmt.println, say array is a, and then I will print slice, say slice s1, and length of the slice. So I say slice length, say length, and I'll print capacity as well. So I'll say capacity here, function cap, and run this program and see the output. So go run slice and go. Capacity is still 3, length became 3, earlier it was 2, and 60 is added to the end of the slice. Earlier we had 30 and 40 only, now we have 60 as well. This output is very important because we had 50 at the end of the array, but now we have 60. The reason behind this is very simple. The slice S1 was pointing to index 2 to 3, and then we had added new element 60 to the slice. So the 60 is actually added to fourth location of the array. The slice is internally pointing to the array. This is the reason the last element of array is updated to 60. We are good till now. We have seen how to create a slice using slicing an array, and we have also seen if we update anything in the slice, it will actually update to the array. And we have recently seen if we append new element to the slice, it will actually update the array if there is a space available in the array. Now we will see what if there is no space available in the array. In our case, there is no space available. Capacity was 3 and length is also 3. There was 3 indexes available and we have filled all 3 indexes. Now we will append one more element and see what will happen. So let's call append function again. Just copy this line and paste it here and say 70 here. And we will also update one slice index element. It's a 0th element. So 0 and equal to 100. And print all 4 statements again after this updates. Just copy this and paste it here, and I'll just say fft.println and separator. Now we'll run this again and see what is happening. Please notice the capacity. Capacity is 6. Earlier it was 3. The reason behind this is capacity of slice was 3 and length it becomes 3. So there was no space available in the slice. Then we added new element 70 to the slice. Since there was no space available in the slice, so append function created new array. And the new array is anonymous array. So there is no array variable which is pointing to this array. And the length of this new anonymous array is just double of current capacity of the slice. So current capacity of the slice is 3. So length of new array is 6. This is the reason the slice capacity is 6, and this is straightforward. Length is 4 because it was earlier 3 and now it is 4. It is very again simple that we have added new value 70 and we just updated uh, new value to 0th element. But there is no impact on this array because the slice S1 is not pointing to this array A, because now S1 is pointing to the anonymous array. So it is not referring to the array A. So that is the reason it is not updated. There is no impact on this array. So even though we changed 0th element of the slice, it did not reflect to the array. So that's it from internal structure of slice. Now we will revisit the slash declaration syntax and understand more details. Let me just clean this console and remove these lines and see more details of this declaration. In this syntax, first index and last index both are optional. If you remove this 2, there is no error. That is error because we just declared but not used. But we'll see what happens if we remove first index and if we remove second index separately. So let me just put 4 again and see what happens if we don't provide the first index. So let me just print this fmt.println and print s1. Just run this program. Yeah, you can see that it start with 0. So if you don't provide any index in the first index, it will take 0 as a default index in case of first index. So that is the reason it slice is starting from 0th element of array. This is similar to if you provide 0 here. So if you run this program again, we'll not see any difference in the output, because again we have explicitly saying that it is starting from 0 and we don't provide it, and we are implicitly saying that it is 0. And so that's it from first index. So if you see if you don't provide second index, we'll see what happens. So if you don't provide second index, it will take length of array as a second index. So if you do, just run this program and see what happens. So here you can see that start with 2 but end with the length of the array. So as I explained earlier, it will take this, if you provide second index here, so it will take second index minus 1. So length of the array is 5. That is the reason it is taking 2 to 4. So index 2 is 30 and index 4 is 50. So it is equivalent to provide explicitly 5, and run this program, we see the same output. So we can directly say here that len, in bracket we can say a. So I'm saying the length of the a should be the last index of the slice. So again there is no difference here, and we can remove both first index and last index at the same time. So if you remove both first index and the last index, it will, the slice will have the whole array, because if you don't provide first index, it will take 0, and if you don't provide last index, it will take length of the array. So it will slice from 0th element of array to length of the array, so it will have the complete array. So just run this program and see what happens. So yeah, you can notice that whatever element we have in the array, we are having the same elements in the slice as well. Now we will see slice initialization syntax. So let me just clean this console and remove these lines and start with slice initialization syntax. Slice initialization syntax is very simple. Just name of the slice colon equal to, then type of the slice int, then the value. So we'll say 10, 20, 30, 40 and 50, and just print this. So fmt dot println then say s1. Just run this again. You can see the slice is printed. Now we will initialize array and see the difference between slice initialization syntax and array initialization syntax. So let me just declare a of integer 5 of integer, say 10, 20, 30, 40 and 50. Run this again. I'm sorry, I need to print it. fmt dot println a, and run this again. There is no difference in output, but notice the syntax here. If you provide index in initialization, it becomes array, and if you don't provide index, it becomes slice. Now we will see built-in functions. We have already seen len, cap and append, and it's time to understand copy function. So let's start with practical. Let me just clean this console again and remove these lines. I'll declare one more slice using make function. Make of integer, let's say 5, and assign it to s2. Let's call copy function. So copy function takes two arguments. First is destination slice and second argument is source slice. So source slice is s1 and destination slice is s2. So it will copy all elements of s1 to s2. So just print the s2 and see is it copied or not. So say s2 and just run this. Yes, it has copied all the elements of s1 to s2. Now we will see what will happen if destination slice is larger than source slice. So what if size of this second slice is greater than first? So let me just change it to 8. So size of this slice is 8, whereas size of this slice is 5. So we'll see what will happen if